Okay, so let's continue our lesson in plotting. Okay, so this time we are going to take a look on the three-dimensional plotting that MATLAB offers. Okay, so there are several types of 3D plotting such as line plots, surface plots, and also contour plots. I'm just mentioning a few. So for the 3D line plots, okay, so as the name suggests, three-dimensional, so it requires a set of order of x, y, and z values as input. Okay, so for example, you have to define the value for each corresponding x, y, and z axis. Okay, and then to plot 3D, we just simply type plot 3 means 3D, three-dimensional, x, y, z, and then you can on the grid, and then similarly you can also label. Okay, this one x label, y label, z label, sin x. You can also include the title. Let's try run. Okay, so this is a spring. Okay, so you can see that the z-axis is labeled the same way that we label x and y-axis. Okay, so MATLAB use the coordinate system consistent with the right hand rule. Okay, so right hand rule lah. Okay, which shows you the x, y, and z direction. Okay. Okay, you can try this just for fun. Try the comet tree function. Let's try the comet tree function. Comet tree x, y, z. Okay, so it will generate an animation sequence of that spring. Okay, so comet tree is for 3D. For 2D line graph, you can use the comet function. Just comet. Okay, next let's look at the surface plots. Okay, so surface plots allow us to represent data as surface. So we'll be looking at two types of surface plots. Okay, mesh plots and surf plots. Okay, so mesh plots and surface plot, which common name is surf, S-U-R-F. Okay, so both mesh and surf can be used to show to good effect with a single two-dimensional matrix. Okay, so let's look at this example. Okay, so in this example, I'm going to mesh and surf plots. Okay, so in this example, we have the value in the matrix that represent the z value in the plots. Okay, while the x and y value are based on the matrix dimension. Okay, try this example of this simple matrix. Oops, no, not this one. Should be z. Okay, and then we're going to use the mesh command, mesh z, and then our labeling. Okay, then run. Okay, so this is an example of a mesh plots. Okay, the graph is a mesh, okay, which is created by connecting the points defined in Z into a rectilinear grid. Okay, so you should notice that the x-axis goes from 0 to 10 and y goes from 1 to 3. So the matrix index number were used for the axis value. For example, okay, note that for Z15, so the value of here, the value of Z in row 1, the value of Z in row, this is the whole row, the value of Z in row 1 column 5, okay, is equal to 5. Faham tak? Okay, dia bagi tahu location Z15 is the value of Z in row 1 column 5. Row Z15 is value of Z in row 1 column 5 is equal to 5. Okay, and then how about you can also use mesh function with 3 arguments. Okay, this one mesh for 1 argument, which is Z values only. Okay, let's try with 3 arguments. Okay, so mesh with 3 inputs lah, especially so x, y and z. Okay, now mesh x, y, z. Okay, let's try run this section. Okay, for you to use this mesh with 3 arguments, your x vector must have the same number of elements or as the number of columns in the z vector, and y vector also must have the same number of elements as the number of rows in the z vector. Okay, so y vector here, okay, kita start with x lah. X vector here must have the same number of elements as the number of columns. So columns dekat z vector is 10, so number of elements in x vector is also 10. For y vector, it must have the same number of elements as the number of rows for z value, z vector here. So z vector has 3 rows, so y vector should have 3 number of elements. Okay, so this is how the mesh looks like. Okay, so this is done. Okay, surf plots. Okay, surf plots are similar to mesh plots. However, surf creates a 3D colored surface instead of an open mesh. Okay, the syntax is the same. Okay, let's look at the example. Okay, now let's try this surf plots. Okay, let's use the sim. Okay, but now we're going to replace mesh with surf. Okay, and then maybe include labeling here. Okay, run. Okay, so now this is surf plots. Okay, and then shading. Okay, this just the appearance. There are several shading options such as interflat and facet flat is the default. Okay, so you can adjust the color scheme with the color map function. This is the default shading. Okay, do you want to try that? Okay, you can try. Okay, let's look at shading function. Okay, for example here, boleh try guna the same plot lah. Shading means interpolated shading. Okay, so this is shading interpolated. Okay, it's the same. Okay, this one shading flat. Okay, this is shading flat. Okay, I'm going to open the figure here. Okay, supaya dia tak override my figure, saya nak tunjukkan the difference. Okay, so this is shading flat, this is shading interpolated. Shading interpolated is here, this one is shading flat. Okay, and you can control the color scheme. For example, color gray here. Ni kalau kita nak control the color scheme, so color map gray here. Here. Okay, so it will force the use of grayscale representation on these surface plots. Okay, so if you want to make a black and white copies of your plots, okay, you can use this color map gray. Okay, there's also different type of color maps. Okay, let's try color map winter. Okay, so run section. So this is color map winter. How about color map hot? Run. Here is color map hot. Okay, you can also try color map. What else you want to try? Spring. Yes, this is color map spring. Alright. And then contour plots. Okay, so contour plots use the same input syntax as mesh and surf plots. Okay, they will create graph that look like the familiar contour maps used by hypers. Okay, kalau you pernah tengok contour plots, geografi rasanya biasa tengok contour graphs, contour maps. Okay, so this is how we can demonstrate the use of different application of different 3D representation, mesh, surface, contour, and combination of surface and contour plots. Okay, you boleh copy all this code and then run it inside your MATLAB. Okay, here is, let me show you this example. Should be common. Okay, then we are going to use the mesh grid function to create two-dimensional matrix of x and y from this one-dimensional xy. Okay, and then we are going to calculate the value of z here. Okay, then this is the plotting code. Okay, so we are going to use subplot. So subplot 1, subplot 2, subplot 3, and subplot 4. Okay, let's see if it's okay. Okay, so here is the different representation of 3D plots in MATLAB. Okay, next, let's look at this color plots. Okay, so similar to contour plots, instead of lines, a 2D shaded map is created. Okay, it uses the same syntax. Okay, look, this is a MATLAB demonstration. Okay, for pseudo color plots. Okay, it for knowledge lah, for you to know that MATLAB can handle a variety of 2D and 3D plots. Okay, so this is example of pseudo color plots. Okay, so here. Okay, so I'm going to demonstrate to you plots, okay, using a pick function that generate x, y, and z matrix on a surface that looks like a mountain range. Okay, so this is the code. It's very simple, you can follow it on your own. Okay, so here I'm going to insert comment here. So here is when we use the surface to demonstrate the use of pseudo color plots. Okay, and then the next part here is when we delete the grid. Okay, when we use the interpolating shading. Okay, next part where we add contours to the image by overlaying a contour plot on top of it. Okay. Okay, so this number 20 here specifies that 20 contour lines are drawn, and the K indicates that the line should be black. Okay, so if you not specify the black lines, the color would be the same color as the pseudo color plot and would have disappeared into the image. Okay, so finally we're going to add a simple contour plot for comparison. Okay, the code is this one. Okay, let's try run. Yes. So this is how the different plots looks like. Okay, so let's see it from here. Okay, this is the demonstration of the use of pseudo color plots. Okay, because the first one have grid, so we are going to delete the grid. Okay, when we specified the use of shading interpolation. Okay, and then we are going to add contour to the image by overlaying the contour plot, okay, on top of the pseudo color plots. Okay, by using this hold on command. Can you see? We are using this hold on command. And then lastly, we are going to add a simple contour plot for comparison. This is just contour plots only, okay, for comparison. Okay, right. Okay, so briefly I've shown you how you can edit your plots, okay, by entering command, okay, either in command window or in editor. But you should know that in addition, to control the way your plot looks like, by using the MATLAB commands, you can also edit that plot once you have created it using the menu bar. Okay, we can do that. Let's try this plot here. So I have this sphere demonstration. Sphere figure. Okay, so this is the insert menu. Okay, so you notice you boleh masukkan title and also X label, Y label, Z label, legend or color bar or whatever. Okay. Okay, you boleh, this is what we call to modify or adjust a figure interactively. Okay, because kita just click from this menu bar here. However, you will lose your modification or adjustment when you rerun your program. Okay, so you rasa okay dah cantik dah figure you ni, tapi you nak run balik. Okay, all this adjustment that you make previously ni will be erased. Okay, that's the disadvantage lah, right? Okay, so it's best if you could type the code in you punya editor or editor lah especially. Okay, kalau macam ni, if you are using this interactive window, you should save you punya figure tu. Okay, creating plots from the workspace is not very important. Okay, so here saving your plots. Okay, so you have to, okay, so every time you have to rerun your M file in order to recreate a plot. Okay, so you can save the figure from the file menu, use the save as function here. Okay, file menu, save as function. So you can save as figure, JPEG, okay, all the images file. Okay, or you can right click apa tu, okay, atau you boleh should be you boleh copy figure and paste into another document. Okay, for example here, okay, so here I just copy figure and paste into a Word document. Okay. Okay, so that's it. That's all about plotting in MATLAB. Okay, hope you boleh follow the content and please get back to me if we have if you have any other question. Right. Okay.